Hello, Sunday the 13th. So the value at the cusps. There we go. Infinity, well, it's of course unity, at naught, which was computed to be minus 1/4, and at 1/2, where we got naught. Actually, before finding the transformation formula, we can immediately see that the value of theta at 1/2 is naught. Because there's no constant term of, yeah, never mind, I'll do that later. And these two will of course be, yeah, we'll have to find out what they are. Now, theta at naught, at infinity, that's obviously unity. We can see that from here. So I'd like to do a little work on naught and 1/2, just to show you that we get q to 1/4, showing that it's naught. So what we need to get started is the transformation formula. Hello, it's now Monday. I decided yesterday to use the time recomputing the values of h and t, but we don't need it for this exercise. Let's get started with the cusp at 0. That's S operating on infinity. So let's make some matrix there. S comma the square root of minus z. We can choose whichever of the 4, and it should give 4 different values, except if it's vanishing, of course. Well, let's call that S tilde. So that's square root minus z to the minus first times theta of minus 1 divided by z. That was not what I expected. Theta of z here. Already here I'm in trouble. Oh no, that's all right, because now we use the transformation formula where we substitute 4z for z. No. Set forth. There we go. And then this, no, it doesn't cancel as it should. There's something wrong here. I'll have to look it up. Oh, what am I doing here? It's a little... Yes, I want 2 divided by I in here. So we take I divided by 2 to minus first. And then we get the right... No, we don't get the right-hand side. Oh my God. So we need to reduce this. So we need to make the substitution I just discarded up here. Right. So we just multiply with this guy. They don't cancel. Oh, it has to be to... it should not be raised to something here. There we go. There we go. And we don't really need to care so much about the values of set here. This gives I set, so it's just the square root of 1/2. And then it's only determined up to a factor of the imaginary unit, -1 and etc. So we don't need to work much on that. And then times 1 plus, etc. So the value is 2 to minus 1/2, 1 divided by square root 2. And that agrees with the fact that theta to the 4th has the value of, minus 2 to minus. Then it is important to take the imaginary guy into account here. So it's like 1 plus I divided by square root, square root 2. So the square is I times, let's see, the square gives 2i divided by 2, that's the imaginary unit, so it's half. So this, yeah, that should do it. And then times t, of course, where, because it's only determined up to a factor of the imaginary unit. Okay, that was a surprise. Next, the cusp 1/2, where we use the matrix one to one naught. Choose the most simple guy. What do we do? It seems to give the same, whatever we do. So let's use this as the left-hand side. And 2 times that, and 1 divided by the imaginary unit, and all this to minus first. Theta of minus so the reciprocal minus the reciprocal divided by 4. And we just put it in here. And reduce. That can't be reduced. So that was the wrong way to go about it. I would like to have the no, that's good. That's the right one. Theta of minus 1 divided by 4z minus 1/2. Now, what does it do to theta to translate it 1/2? Then this guy changes sign. That's an entire new function. It's not an entire function, it's an entirely new function. I had really hoped not to have this complication stemming from a non-integer here. I'd hope like being able to use this formula. Well, time for a coffee break, I think. And maybe I should have gotten the idea that, but the odd ones were difficult to get, so we have just to subtract the other ones. So whether we subtract or add 1/2, that gives the same. So it's 2 times -1 divided by z minus phi of -1 divided by 4z. The first one here, we substitute, up here we substitute z4 for z. So the square root comes on the other side. So this basically cancels except from this guy, which gives 1/2, that cancels this half. Etc. So it cancels and we get 2q to 1/4 plus 2q to 9/4 plus 2q to 25/4, and you can see we can put out q to 1/4. 6, that's the triangle numbers we get here. Meaning, of course, it gets naught, as we knew it would. I just wanted to verify that the expansion had the form that was stated. We have t equals minus the imaginary unit, and that means the r value is 3. Or was it c to minus k? There's a little uncertainty there. It was just the final section, the final paragraph of the section that I wanted to test, that we get q to rth times a normal series in q with integer exponents. So that means that r should have been 1, so it's 1/4. Well, it's probably right, though I just didn't get it here. All right, that was the expected values, this one, and that was a mistake by my part. That was my mistake, not realizing that the 4th power was negative.